I welcome you all to the second session of this seminar, Energy Efficiency in Building. Uh, Let me first introduce you, the speaker of the day, Mr. Girish R Visvanathan. Mr. Girish is a seasoned sustainability professional and specializes in the field of energy analytics, including energy simulation, energy efficiency, strategy formulation, ventilation designs, automation, and retrofits. He's bestowed the IGBC Fellowship Award in 2020. He works closely with Green Building Council and is a sought after lecturer across the popular universities in India, Middle East, and Australia. To his credit, he has facilitated several national award winning projects with digital twin approach, the first platinum rated green factory in India, which is the highest rated green factory in the country. He has also commissioned the first ever green building in Northeast India, a full-fledged gold medal rated hospital for the underprivileged that also attracted appreciations from Bill Gates himself. He was part of the first ever green retrofit of a central government building in India and also is one of the highest rated retrofitted green building in the whole of India. He continues to support and bridge the industry academia gap via R&D initiatives, mentoring programs, and projects focusing on advancements of green building technology. I now hand over the session to Mr. Girish. Sir, you can take over the session.
Thanks a lot for the introduction. So I hope I'm audible. I'm also going to share my screen right now, a confirmation if my screen is visible. Specifically the presentation. I hope you can.
Yes, sir. It's visible.
A very quick check if you can see my slides moving. Just a second.
Yes, sir.
Okay. All right. Thank you so much for the introduction, and always happy to meet the faculty and the student force from from the same city. It's always a pleasure. I'm pretty sure it would have been a lot better had we had this interaction face to face. But given the gravity of the situation, and we also understand that we are very slowly coming out of this, so something is better than nothing. So virtual catch up is probably not as good as a face-to-face catch-up, but having said that, I'm pretty sure we'll have an opportunity to meet face-to-face and have a lot of interesting interactions in future. So thanking CII IGBC for the opportunity, and also to the host for giving me this opportunity to present today. So the topic given to me is energy efficiency in buildings, and we are very specifically going to focus on this aspect of a green building, which across the rating systems it's given the maximum preference. Now the reason is very obvious. If we can cut down on our energy consumption, it just does not result in profits to the person who owns the building, but it has a larger ramification in terms of what it does to the environment as a whole. Number one, it definitely reduces the carbon emissions associated at a building level, and if 10 or 100 such buildings do it, we do not have to talk about the implications of what can happen at a community level. Number two, even though India is marching towards the status of getting all its village electrified, there are 14% of villages today that do not have 24 hours of power supply. I can understand that, compared to the last decade or so, we are in a much better position, but then there is an opportunity wherein this need not be just a government initiative, but people like us can cut down on our consumption, and as a byproduct this power can be diverted to other places across the country where there is a shortfall. So definitely there is an opportunity to help the community as well. And finally, We are also at a crossroad wherein global warming is going at a really high level. So cutting down these emissions is going to benefit the planet as a whole. Okay, so we will come to this test of sustainability as we go through the presentation. But going ahead, just a quick introduction of what I do. I'm the director technical at Earthonomic Engineers. I also head the R&D at a Singapore-based company called Chi Square, wherein we work very closely with the Nanyang Technological University to develop state-of-art tools to estimate how quickly a building can be converted into green. Having given this introduction, let me just go forward. So, Earthonomic, I think the name speaks for itself, where Earth meets economics. Why this very specific name? As we see currently, what is happening today is that people see green buildings and environment as a cost vertical, which means it is a thing that is good to do, it helps the environment, but then for the person or the entity that's doing it, it is going to be an issue because they take a look at it as a cost center and not as a profit center. Now, we would like to break that particular assumption that is there, because if done right, Earth, the sustainability or the initiatives that promote Mother Earth's longevity actually also translate into profitability. So how do we exactly do that? So very quickly, before I get into the core of the presentation, I'm pretty sure all the audience here knows about these factors, what a green building can do in terms of reducing the power demand, reducing the GHG emissions, water consumption, energy consumption reduction, increase in green cover, that by reducing the heat island effect. Heat island effect is nothing but when we have too many exposed surfaces in terms of roads, pavers, etc., they absorb the heat and increase the urban temperature by anywhere between 5 degrees Celsius to somewhere between, during the peak times, it even goes up to 10 degrees Celsius. So these issues are there because of the fact that greenery is being destroyed on a rampant basis today to promote construction. So that balance is also required. Apart from that, we also have very, very good plans to recharge our aquifer system so that water does not run into the sea or into the rivers or into the canals, and rather it is sent back into the ground so that whenever there is a requirement, we are benefited as a community. And finally, because of doing all this, the pollution also reduces and the indoor air quality. So currently we see that the air is so polluted. Probably a year back when we were amidst lockdown, we did see that the air was so pure. In fact, we also saw there are so many memes going around all the social media platform wherein the air is so pure that people's visibility of structures nearby, and even at a sky level we could see more stars. So all that was going around, that is absolutely true. When activity and pollution comes down, the air quality improves, and when the air quality improves, the visibility also improves. So overall there are productivity gains because people are much more happier when they breathe in fresh air and get access to visuals that we usually do not have. Okay, these are certain national benefits of going green. Now as far as tangible benefits are concerned, energy and water savings up to 30 to 40%. Now this has been very, very well documented. People who have been going green seriously, not just from a certification perspective, but by doing all the right things required for certification, or let me put it this way, not just by designing the facility green, by operating the facility green as well, they are able to realize this 40% energy savings. Now the intangible benefits, as we were talking about, improved indoor air quality, really good daylighting, health and well-being of the occupants, and finally safety of the workmen also. Now I would like to slightly stress upon the third point here, which is health and well-being of the occupants. Now technically, if you see, after COVID norms came into place, most of the government bodies or bodies like CII, all these expert committees ask us to do one thing very specifically: keep your doors and windows open. Now the concept is very simple. Just like Flowing water does not breed mosquitoes. Flowing air will not breed pathogens. Only if the same air is recirculated again and again within the facility, there is danger of us contracting any kind of pathogen, let alone COVID. Let us say somebody has even a very basic viral infection in the same room that we are in. If the adequate number of air changes are not there, or fresh air is not there, and let us say we keep using the same split AC which circulates the stale air again and again, in that case my neighbor has a very good chance of contracting the disease from me. So from that perspective, when fresh air is there and continuously evacuation of stale air keeps happening, the place becomes much more healthy, and that is the reason why green buildings also promote health and well-being of the occupants, precisely because supplying fresh air to a conditioned space is a mandatory requirement, and keeping your doors and windows open in a naturally ventilated space is also a mandatory requirement, both of which very clearly promote the health and well-being of the occupant there. All right. Now, given this, what now we have quickly taken a look at the national scenario. Let us take a look at what is happening globally. Globally, if you have been watching the news, and if you have been watching the promotions that are being done by various top-notch companies, the MNCs, they are all trying to adopt the sustainable development goals, wherein taking initiatives that not just add to their line of profitability, but also helps other aspects of the community benefit. For example, green buildings take care of the points 3, 7, 8, 9, 11, 12, 13, 15, and 17. So 3 is good health and well-being, which we just spoke about. 7, affordable and clean energy. When you start consuming lesser power and start depending upon renewable sources of power, your cost of consumption comes down. So affordability increases, thereby there is profitability to the owner. So number one, the occupant is benefited. Number two, you can see the owner is benefited. Decent work and economic growth. Now, if a place is happy, if it is bustling, if it has got so much energy, if it has got daylighting, if it is much more comfortable, obviously people want to work out of office, correct? And then there is also industry, innovation, and infrastructure, which is one of the key topics of your seminar, is what I understand. Automation is something that you're taking care of. Innovation is something that you're talking about. So all this is also coming into the picture. Point number 11, sustainable cities and communities. Now, if I can save 30 to 40% power at a building level, imagine what I can do at a community level. Then imagine what we can do at a city level. And then if we have a success story, then we can completely extrapolate and replicate the same models across various parts of our country. So not just at a home level, we can take it to a commercial or an office level, then we can take it to a community level, which can further feed into a state level, and finally the benefits can be passed on at a national level. Now this should be our larger goal. If you take at point number 12, 13, responsible consumption and production, I don't think I have to dwell upon this. Whatever we consume more than our requirement is, we are probably affecting somebody else's requirement. Probably that is the best example of sustainability here. Consuming what is required and not over consuming. Now, under consuming is also an issue, but then the right amount of consumption helps plan, forecast, and allocate resources better across the supply chain. So not by being responsible, I not only take care of my requirements, I also make sure there's another person who might be starving for the day, his requirements are met. Number 13, climate action. Obviously, because of all this, the environment benefits as a whole. Like, for example, just to give you a very quick example, we did take a look at urban heat island effect, which is one of the key areas of concern today, wherein city temperature. Just to give you an example on a particular case study that we had performed about 2 years ago, the temperature difference between IIT Madras, if you know, one of the densely there's a lot of dense tree population. There's a lot of trees there. There is a lot of tree cover and foliage there, and these are also native species that are dense in nature. Because of which, even though the temperature outside was 42 degrees, the temperature recorded in a place like IIT was about 40 to 41 degrees Celsius. Whereas exactly 3 kilometers away, on the OMR, on the old Mahabalipuram road, where there is not too much tree cover, we measured about 51 degrees Celsius. So that could be a difference between whether your environment is cool and as a byproduct of which you consume lesser energy, or is it going to be so hot like OMR road in summer, wherein you end up expending more energy and people are much more uncomfortable when they step out. Okay. That also translates into life on land. Now, as I have more number of trees and more number of more amount of foliage and more amount of greenery, it also promotes other life forms. For example, birds, squirrels. There are so many kinds of insects that dwell so much on the depend on the trees for their feed. So all that also proportionally increases. And finally, point number 17, partnership for the goals. Wherein all these, when they come together, we talk about happy communities. Okay, so just to summarize, many companies today are incorporating sustainability practices to boost brand value as a part of their revenue strategy. And in line with this, sustainability benchmarking and reporting is being actively pursued. And as we exactly mentioned earlier, now green buildings are a significant portion of this particular bouquet of services. They focus, as you can see, about 9 out of 17, that is technically more than 50% of all the sustainability goals can be taken care by a green building. Okay, going forward. All right. So we speak so much about sustainability in so many other ways. We say that it is going to be beneficial to the environment, it's going to be beneficial to the planet, it's going to be beneficial to the people, it's also going to be profitable. So, how does one check if a solution is sustainable or not? Now, I'm getting into the specifics of green buildings over here. So, the test for sustainability is very simple. As you can see on the left hand side, test for sustainability is if a particular solution benefits people, planet, and is profitable, then it is absolutely sustainable. Let me take a very small example here, solar panels. Okay, how does the solar panel benefit the planet? It is a zero carbon emission based electricity production source, which means I do not burn any fossil fuels to produce it. I do not have to expend, I do not pollute the environment while I produce energy. So for the planet, it is a renewable source that is converted into electrical energy. It benefits the planet in a really good way. How does it benefit the people? Now let us take the base case. We always know what is our India as a country. The conventional source of energy is thermal power. And we know how thermal power on one side sitting in the city, we are absolutely fine and experiencing the luxuries of thermal power. But if you take a look at what happens to people around the place where thermal power is generated, the water is polluted, they are exposed to radioactivity, even because of coal mining, you do have radioactivity to a significant extent, and then pollution, as I already told you. Finally, last but not the least, this is still a combustion process which is going to release a lot of sulfur, hydrocarbons, and associated chemical pollutants into the air, and the people around are still facing issues because of this. So, solar panel compared to thermal power plant absolutely benefits the people, again because there are no hazardous emissions associated with solar panel. And finally, profit. After the first 2 or 3 years, after which there is a payback, it is absolutely free power for the next at least 15 years. So as you can imagine, it ticks all the 3 boxes, which is beneficial to people, beneficial to planet, and beneficial to profit as well. Another such example is LED. So earlier we used to use CFL, which is harmful to the planet because after CFL's life is over, we dump it into the landfill, and all the mercury from the CFL goes into our water table, and in turn we consume the same water and we have health issues coming up. So it is obviously not good for people, whereas LED is 100% recyclable. Thereby, it benefits the planet. Now, people, CFL, there is an issue because it emits heat along with light, and there is a lot of other UV content as well, which is not good for people, and also there are certain poisonous gases as well. Whereas a solution like LED does not have this issue because it just processes the power and emits the light. And finally, profit. LED consumes 50% when compared to CFL, thereby 50% reduction in energy bills. So if you want to quickly check up if a solution is sustainable or not, you just run it through this test, whether it benefits the people, benefits the planet, and is going to deliver profits. So the same way, if you can take a look at, let us take a look at green buildings on the whole. Okay, it is going to tick all the three boxes. Number one, it is inherently designed to make the best use of all natural resources. Thereby, it benefits the planet. Okay, much more environment friendly than a normal building, because the recycled content is there, because there is there is obviously going to be benefit to the local environment as well. Finally, secondary aspect, it is also going to consume lesser energy, lesser water, which turns into profitability. Last but not the least, as I told you, because of more daylighting, because of more ventilation, because of more facilities that promote health, it benefits the people as well. So this is the triple bottom line. So you can note this down. This is the best way to test if a solution is environmentally friendly or sustainable or not. Certain other examples I can talk about that tick all the three boxes: rainwater harvesting. Electrical vehicle today benefits all the three. So there are many host of other solutions. So very quickly, even to assess if a policy is sustainable or not, you quickly run it through this test and you're going to have your answers. Now, coming very specifically at a building level, a building should create delight when you enter, healthy when it is occupied, and regret when it is departed. Now, this is exactly what a green building does. Because of the increased oxygen content, because of the increased daylighting, the vibes or the positivity associated with that place is much more compared to a conventional building, which might not be constructed taking into consideration the aspects of a green building, and hence you might not get the same experience when you enter a normal building. Okay, so all the other things we have just discussed: reduction in results in low cost, maintenance is also low, improved brand image is the final aspect. You also get this, and most of the MNCs go for this. Reduced utility cost and reduced operational costs are the same. Environmentally, definitely responsible, so it benefits everybody. Now, coming to the building segments very specifically, there are two ways in which we can handle how energy efficiency in buildings is going to play a majority role. A new building, and B, existing building. Now, as the audience here is mostly out of, I'm assuming most of us are from the civil background. So we know that the current rate at which construction is going to go through in the next 10 years to 15 years, there is going to be a huge boom in the construction sector. So new building, even if I save 20 to 25% energy at a single building level, it is going to have a multifold effect, or if I have to call it the right way, an avalanche effect on a city level or on a national level. So this on one side. On the other side, there is also the existing building, wherein 80% of the buildings that exist today will continue to exist in 2050. All right. So with 80% of today's building continuing to exist in 2050, that is also a potential market for us. Not just the new buildings have to be taken care of, all our existing buildings again have to be retrofitted so that they become environmentally friendly. So both these sectors have to be given equal preference. Now, as civil engineers, I do understand that new building has a higher preference when compared to existing building, but then we should also understand that there is a huge potential in existing building, and that should also be captured. So just to have a very quick walkthrough of this, a new building, you can take, there's so much flexibility. You can put in any technology that comes into the sector into a new building, and take a look at how each of these technologies contribute to the building's performance. Okay, right from the design, right from the HVAC, right from the indoor environment quality, occupant comfort, how much daylight comes in, how to integrate all this and package all this so that the building operates in a really smooth manner. So new buildings, sky is the limit. Any technology that comes up can be shortlisted for the building, and if found to be financially viable, can be implemented in the building, and when implemented, can pass on a lot of benefits to the people, environment, and finally, it is also profitable to operate. Whereas, when I compare an existing building, I do have an issue. There are very small limited. There's definitely a limitation in the way in which I'm going to operate an existing building. So there are only certain changes that I can make. There are only certain demolitions that I can do. There are only certain renovations that I can do, and I have to do all this without disrupting the operations of the building. So things get a little difficult when compared to a new building. However, the advantage with an existing building is that there are foolproof technology today. All the solutions, let us say there are about 50 solutions. I have a bouquet of 50 solutions. I can very easily map the impact of each of these solutions on the building, and I can measure the impact of these solutions by using a very, very intelligent or a smart metering system. So, having given you an idea of how green buildings is going to apply for new building and an existing building, let me jump into the concept of existing building. Let me start off with a new building. I kindly request you to give me a heads up whenever there is 5 minutes left and whenever we have to get into the question and answer session, so that I can plan my presentation accordingly. I hope that's okay, sir. All right. Okay. Let me just continue. So, new buildings. How do we handle new buildings? So, the most developed and the most advanced tool that is there in the market today is a building energy simulation tool. And the building energy simulation tool currently in the last year or so has also been labeled as a digital twin. Now, what is the concept here? Concept is very simple. You can create a digital copy or a virtual clone of a particular building, and once you create a virtual clone of a particular building on a server system or on a computer system, you can do all your design testing on this particular building, and once you complete this design testing, you can rank your solutions from 1 to 10 or whatever it is, and identify what is the contribution of each of these solutions to the building's green factor, to the building's sustainability factor. So having said that, what are the various things that I can take a look at? After doing a 3D modeling, I can estimate how much daylighting is going to come into the building. What is the solar shading analysis? As you see here, if there is a neighboring building, is that going to shade my building, or is it going to be an exposed surface, natural ventilation? For that particular climatic condition, if I integrate the weather file and keep my windows open, am I going to have the adequate number of air changes, and is my oxygen level going to be high, and thereby am I going to benefit the people inside the building? That can also be tested. You can test materials, you can test HVAC, you can also estimate how much energy this building is going to consume on an annual basis. Let us dive deep into these aspects one by one. Okay, so once the modeling, so as the first step, we do have to do 3D modeling here, wherein we'll have to model the building, or in case any model of the building is there, we can export it to the platform. And once we export it to the platform, we can very easily assume certain factors and see what is the impact of those factors on the building. Okay, the most important from a civil engineer's perspective is material analysis, wherein to this 3D model, you can apply different materials on the software and see what is the HVAC load associated with each of these materials, and thereby you will know three details. Number one, what is the cost of the material? Number two, what is the HVAC sizing? So you'll know what is going to be the estimated cost of the AC system. And number three, how much is it going to consume? Okay, using all these three data, you can very easily classify which is the best material amongst the choice of materials that you have. I will show some examples as I go forward. So this is one aspect that plays a very, very important role. If you can take a look, I have put up a dummy building here, and I am trying to check up two orientations. Number one, longer facade over north and south, and then longer facade over east and west. If I have a doubt, what I would very simply be doing is simulate both these conditions and see for which condition is my temperature lesser inside. Yes, you can do that. After simulating a building with a particular material, you can go to each and every floor and check up what is the floor temperature or what is the air temperature in that particular floor. That will give you a very simple idea of which orientation would make the best sense for this particular climatic condition. All right, going forward, what can I do? There is sun path analysis wherein I know which direction the sun moves, not just on a daily basis, but on an hourly basis for 365 days. So I have data points for 365 into 24, which is equal to 8760 data points. Now, for each of these data points, I can estimate as to how the building is performing, and this in combination with the climate analysis, the external temperature, the wind flow, the humidity, all this can be taken into consideration, and I can get my daylighting design done, I can get my material selection finalized, and finally I can also confirm what is the kind of ventilation that I need to make sure that the building occupants are going to be comfortable when the building gets operational. So just by getting the orientation right, you can see that three major aspects of the green building can be covered, including daylighting, material selection, and ventilation. And when I talk about ventilation, this also includes the air conditioning of the building. So there would be mixed mode buildings wherein certain portions of the building are going to be naturally ventilated and certain portions of the building are going to be artificially ventilated, or in other words, conditioned spaces. So both can be taken into account. All right. As I told you, daylighting, you can see this is the result. By putting in openings in various facades, I can actually estimate what is the percentage of daylighting across my floor space. Okay, and this lets me identify if I need to increase the window area, if I need to decrease the window area, if I need to change the type of glass so that more light comes in. If I take a tinted glass, lesser light will come in. It might make absolute sense for a place like Chennai because sunlight and daylight is abundant, but if I capture a lot of sunlight and daylight, my AC bills will go up. Okay, so I have to strike a balance. How can I strike a balance? By varying the openings of the window size and by selecting the right kind of glass with this right tint. This is very simple example is when we go out in the sun in summer, we wear sunglasses so that the heat does not hit our eye and it is filtered to such a level that my eyes are extremely comfortable in looking around. So the same aspect applies here. Material selection, yes, by changing each of these materials, there is AAC wall, there is brick wall, there is porotherm. For each of these materials, I can see how much heat comes into the building, and thereby I can also estimate the air conditioning load required for the building. And when I map these two, I know which is the most financially viable option to me, and as a byproduct, not just it is financially viable, it is also going to become the energy efficient option. Last but not the least, as I told you, there is also ventilation with which I know which direction is the wind coming from throughout the year or even on a monthly or a daily basis. And using this data, I will exactly know how to capture the natural resources to cool my building directly. So these are certain potential opportunities. What I can also do is take a look at what is the heat map for each of the facade. North side, how much heat is coming, west, how much, east, how much, south, how much, and if you can see, roof gets the maximum amount of heat. So using this in advance, I can decide to categorize my investment on surfaces that are probably more susceptible to heat ingress than surfaces which are naturally cooler. So it lets me analyze this as well. Going forward, the same thing with north and south orientation. So for this particular orientation, if you can see the heat map, roof is getting the maximum and north is getting the least. So using this, we can very easily estimate which is the best orientation for the particular building. Coming to product performance analysis, as you can see, there is something called cool roof tiles and paints, by putting which we can estimate without this effort, the tonnage is 31 ton of AC requirement. However, if I put this on my roof, there is a drop of 8 ton. So the amount or the investment spent on this particular energy efficiency feature or civil feature can be mapped to your AC consumption, and thereby this cost might be far lesser than the cost saved via 8 tons of AC. So this mapping very easily helps you design a really healthy and a really green building, energy efficient building. Porotherm, as you can see, is a product that has a lot of porosity in it, and air, as we know, is a natural insulator. So what is naturally 31 TR? If I had constructed the same building with this kind of a block, would require only 23 TR. Again, you can estimate or map the payback. AC saved is about 8 TR, and 8 TR today in the market is 50,000 rupees per TR. So for 8 TR, I'm going to save 4 lakh of rupees. Whereas the incremental cost on this particular product must have been only 3 lakh of rupees. Thereby, by going for a greener option, I'm saving 1 lakh elsewhere. So this mapping is very important to make sure that we generate healthy and green buildings. Some other examples as well, as you can see, this is a product called Sinicon PP. It is a IGBC green product, a certified product, wherein this plaster is so energy efficient because of vacuum volcanic balls in its mix that it can reduce the same TR by 6 TR. Again, there is something called expanded clay aggregate. If you put it on top of your roof, the heat reduction comes down by 50%. So what originally for a 10,000 square feet facility in Chennai would require 43 TR, by the application of this particular product comes down to 21.5 TR, which is a significant, which, you know, if you can see, 20 TR into 50,000 rupees is about 10 lakhs of savings, whereas the product might have cost you only 2 lakhs, thereby passing on a benefit of 8 lakhs to the owner, plus the cost of operating 43 TR is double to the cost of operating 21 TR. So you not only make a savings in your capital, in your investment, but you also make savings in your operational costs. So this mapping is very important to estimate how green your building is. Going forward, there are so many other solutions. As you can see, there is MICS, monolithic insulated concrete surface, which can cut down the heat that comes into the building by 75%. As you can see, this is a 200 square feet, no, this is a 400 square feet home that required 2 TR. With this particular surface will require only half a TR. And then there is also something called as HVLS, high volume, low speed fans that can keep circulating air on a continuous basis, and thereby, even if the external temperature is 41, because continuously heat is evacuated, the internal temperature can be, on the worst day, on the really hot day, can be evacuated with continuous circulation and maintained at about 38 degrees Celsius, giving a very, very simple benefit of around 3 degrees for a space. All right. Going forward and being quick here, what are the other technologies here? Not just materials, you can also see how selection of lighting systems or polycarbonates on your wall can ensure free daylighting across your system. So this is a building in Gujarat, it's an automobile factory, wherein we have removed the skylights and made them into wall lights so that there is no heat gain and there is only light coming in from the sides. And this particular facility gets about 300 lux of free lighting from 9 a.m. to 5 a.m. every day. If you are wondering why this space is not getting lighting, this is basically a paint shop wherein they want to take a look at the facility in showroom conditions and not in sunlight conditions. Finally, there is also a very, very recent technology called BIPV, Building Integrated Photovoltaics, which helps you generate solar energy not only from the roof but from the walls as well. So instead of your glass and instead of your sunshades, if you can integrate solar panels, and let us say there is no shading on those particular directions, your walls can start generating power just like your roof generates power using solar panels. Now, you might be thinking that the power generated from your walls is going to be the primary benefit of such systems. That is absolutely not right. Okay, the primary benefit of this particular system is the reduced consumption because of lesser heat coming into the building. So your primary benefit is lower AC cost. Your secondary benefit is that it also produces power. So things like this can be very, very, very easily mapped in a real-time basis, and you can take a decision as to whether the building is going to be sustainable or not, and whether the solution that you are going to propose whether it is going to make financial, environmental, and people specific sense or not. So this snapshot is very easily available to you when you do a building energy simulation, and when these benefits are passed on to the building level or at a community level, you can imagine what kind of benefits we can expect at a national level. Going forward, just a very quick case study. Now, this is the building that we were talking about even during my introduction. This is the first green building in the northeast of India. As you can see here, it is a building wherein we have used natural resources to a great extent, and we have gone for the pocket type of architecture. Why? Two reasons. This building is 2 kilometers away from the Brahmaputra River. Okay, and when you are 2 kilometers away from the Brahmaputra River, you can, what we saw that, see, the Brahmaputra is on the southern side and the Tibetan plateau is on the northeastern side. So there's a continuous wind coming in from the northeast side and joining the Brahmaputra. So if you imagine like this, if you go to the beach, you see that the beach always gives you air continuously. There is airflow that is coming from the shore, right? Exactly opposite is what happens with the river. In whichever direction the river flows, air currents move in that direction. So this facility being exactly between the Tibetan plateau and the Brahmaputra, there was a huge volume of air current moving through this particular site, and that is the reason why we decided to capture it using this pocket kind of architecture. So no matter which season of the year, which direction the wind goes, it will have to pass through the building. Over and above, we gave significant amount of bamboo cladding to this building, so that because of bamboo cladding, what happens is the overall temperature of the facility comes down, and even if the air is moving at a higher level, it is going to use this particular bamboo as a heat sink, and it is going to get attracted towards this building. So I take care of two aspects in one shot. Number one, significant amount of oxygenation inside a building, and considering this is a hospital building, continuous evacuation of stale air actually helps people's health, helps their recovery rate, and finally we could remove 60% of AC across the building because naturally the air movement was cooling down this building. Okay, and this benefit was passed on to the underprivileged people of the place. So this is the building for which Bill Gates actually gave me a tweet and said, this is the way we should be constructing more number of buildings, and we should be promoting green buildings by adopting technologies like these. And it also became an international publication journal in the Earth Day network, wherein it became a case study as to how we caught the wind to make this particular facility extremely energy efficient and at the same time extremely healthy. Okay, going forward, now just to have a little bit of fun, we all know who this is. He's Tony Stark. What does he do? He's a billionaire, he's a philanthropist, he's a scientist. However, if somebody were to retrofit Tony Stark with the latest gadget and gizmos, what would happen? We would be getting Iron Man, and who's Iron Man? A superhero. Okay. Now the case with respect to buildings is not very different. Now this is exactly my case with existing buildings, wherein if you take an existing building and retrofit it with state of the art technologies, gadgets, and solutions, you can have a super building which is green in nature. So that's exactly what I've tried to convey here going forward. All right. So what is the need for retrofit? Again, as I told you, 80% of all the buildings that are going to exist today are going to continue to exist till 2050. And because it is going to continue to exist till 2050, if they are not green, they are going to be a liability to us. They are going to be a liability to the environment. They are going to be a liability to people. They are going to be a liability to the planet as well, because they are going to consume more energy. So considering all these aspects, we will have to retrofit these buildings. All right. So climatic changes, health and well-being, environmental impact, economic and financial impact, and finally energy demand. All these aspects will be taken care of. very quickly going through. So what entails energy efficiency in an existing building? We have seen in detail what happens with a new building. Now quickly going through for an existing building, we need very good metering systems, because what can't be measured cannot be monitored and definitely cannot be optimized. Only if we meter the consumption of the building, we know which segment is consuming more, which segment is consuming less, and thereby I can focus my investments on very specific segments. Okay, and that is the right way of doing it. Instead of shooting in the dark, I actually have a good shot at my aim, and thereby I can pass on maximum benefits to every stakeholder that is involved in the building. All right. So, what are the major energy consumers in a building? Lighting, equipment, HVAC, equipment, lighting, and miscellaneous that includes lifts, motor pumps, escalators, etc. So, these are the core energy consumers in the building. And then, how do I do a monitoring? So, today there is something called BMS system, Building Management Systems, wherein somebody has a dashboard of all the consumptions that are available for the building, takes a very close look at this particular building, takes a look at various consumptions, and with this data he is able to optimize many aspects: energy, lighting, whether there is temperature increase and fire somewhere, what is the water consumption at various zones of this particular building, how much energy is the AC consuming, does the elevator require maintenance because it is getting stuck or consuming extra energy. Not only that, he can also integrate the security and access, because the same BMS system, as you might have seen in most of the movies, can also take care of a security system as to they know where people are moving around, which corridor is occupied, which entry is having some activity going on. All that can be seen. And last but not the least, today this can also integrate with your EV charging points to see how that is consuming energy from your building. Okay. Quickly moving on. So this is the split for India. This is the most very basic average split of across our country. Almost 50% of our power is consumed by HVAC, 20% by lighting, roughly about 30% by equipment, which includes printer, scanner, fridge, TV, all the other equipment except your AC is included in this, including your ceiling fans, any other system, pumps, motors, etc. And finally, you also have elevator or escalator loads and some amount of parking fan load. This is very minimal because these are very segment specific loads. All right, so very quickly going through what are the opportunities to retrofit. If you just by upgrading to LED, you can save 50% of power. Obviously, because LED per unit of power consumed gives higher amount of lighting output. Second, the daylighting sensors, they alone can pass on a benefit of about 25% savings, because whenever there is daylighting in a particular place, that place artificial lighting wouldn't switch on. Occupancy sensors, when only people enter a particular room, lights will switch on. So no behavioral losses of energy, wherein when I'm going out of my room, if I forget to switch off the lighting, that kind of issue will not occur. Okay. And last but not the least, dimmers and IoT, we'll come to this later. We can use IoT technology. For example, in a conference room, when a presentation is going on, we can dim the lights to 20% so that the screen is very well visible, and that can pass on another 10% savings. So just from lighting, we can cut down our existing lighting consumption by as much up to 60% to 65%. Case in point, this is a building in Hyderabad, wherein this we have already seen, this case study we have already seen, where I have used natural lighting to save energy in an existing building. This is a place where we have used lighting simulation to estimate how much lighting comes into a particular building at a particular time, and thereby we put in sensors at various locations in the building such that I set my lighting level at 350 lux. My daylighting gives me about 110 lux. So whatever the shortfall between 350 to 110, roughly about 240 lux is taken care by my artificial lighting. Thereby, I get additional energy savings as well. So these are certain aspects of IoT and dimming technologies. Under envelope, wherein you civil engineers have a very, very huge role to play, 7 to 10% savings just by picking up the right elements, performance glass, glass films, using shading elements like trees, chhajas, and sunshades, using heat resistant plaster to cut down the heat that comes in. SRI treatment for roof is nothing but white paint and white finishes on your roof to reflect the heat away. These opportunities are there. And finally, in AC, if you can see, there is an opportunity to cut down cut down consumption by using variable frequency drive. What a variable frequency drive does, I'll just quickly cover the points. VFD is there. There is DCV, which is demand control ventilation, HRW, which is heat recovery wheel, and system COP as such. Now, this is the example. Now, VFD supplies cooling only based on demand. So if a room has 10 people and another room has 2 people, the room with 10 people will have a higher refrigeration flow to take care of the cooling demands, whereas the room with 2 people might operate only for 10 minutes in an hour because that is enough to take care of their cooling requirements. HRW exchanges the chillness between outgoing stale air and incoming hot air. Outgoing stale air is really cool because it has already been treated for, it has already been cooled down to 24 degrees Celsius, whereas the incoming hot air comes in at about 40 degrees Celsius. So if I pass the chillness on from the outgoing stale air to incoming hot but fresh air, I can get a lot of savings as well. And last but not the least, today, this is one IoT technology that plays a very important role. It is called DCV, demand control ventilation. So it takes a look at the CO2 level in a particular room, and if the CO2 level in a particular room is high, then it will supply fresh air. So fresh air is not continuously supplied, it is only supplied whenever there is a requirement. Why this plays a very important role? Now fresh air is coming in. For example, in Chennai, it will come in at 40 degrees Celsius and 80% humidity. So to treat fresh air from 40, 80 to 24 degrees Celsius and 60% humidity will require a lot of energy. So instead of continuously giving this fresh air, I will only give fresh air based on the occupancy in the rooms, and thereby I will save about 15 to 20% additional energy. I can also save energy in lift just by having a very small sensor, so that only when somebody comes into the lift, the light and the fan inside the lift will switch on. There is also something called regenerative braking. So what happens with the regenerative braking is whenever it goes down, it will produce energy using gravity. So whenever it goes up, it expends energy. Whenever it comes down, it generates energy. Very similar like the electrical vehicle today. Whenever somebody brakes an electrical vehicle, the current flow goes from the motor back to the battery. So the same concept is being used. Rather, if I have to be very, very frank here, elevator concept has been extended to EV, electrical vehicles today. Then you can also take a look at equipment. There are DC fans today. If your AC fan is 80 watts, your DC fan is only 30 watts. Energy saving is there. We have already seen on-site renewable and BIPV or similar technologies. And if I can seal my building properly, energy savings improve there as well. For existing offices, there are USB monitors today that require only 5 watt of power as against 45 watt of power, giving the same kind of output. Now you can imagine the kind of savings if thousands of people opt for these energy efficiency monitors. So 1,000 people into 50 watts is roughly about 50 kilowatts, whereas 1,000 people into 5 watts is only about 5 kilowatts. So you get about 90% savings is possible. Going forward, there is also something called as a super fan, wherein I am using DC motor instead of AC motor, and DC motor is 80 watts. As I told you, AC motor is only 30 watts. So you can imagine the energy savings. Every motor will give you 30 by 80, 3 by 8, roughly around 60% savings. All right. We have already taken a look at this particular concept, BIPV, wherein I can shade my existing building's facade with solar panels so that the heat coming into the building reduces. Not just the heat coming into the building reduces, I also generate power from my facade. How cool is that? So such technologies are there in the market today.
So just a
Yes,
reminder, we have 5 more minutes. Sir.
Thanks a lot, sir.
Right. Just to remind, if you have things to say, you can still continue.
I'll try to cap it up in the next 5 to 7 minutes so that we can spend significant amount of time, let us say at least 10 to 15 minutes in the question answer session.
Sure, sir. Sure.
All right. Now, what is the next after all this? We know how to design an existing building. We know how to design a new building. We know that all this passes on benefit to the environment. But the next big thing that is coming up in today's market is net zero, wherein I am able to take care of my own needs. All right. So, how do you do it? There are something called ECMs, energy conservation measures, and each of these ECMs contribute to the building in a particular manner. And when I start combining these energy conservation measures, the end result is extremely fruitful and beneficial. Let us just take a look at this. So ECM 1 is just by putting energy efficient lighting. Okay, just if I do a lighting calculation and use just the amount of lighting required to take care of my needs, I can cut down significant amount of energy. Then there are fans we saw. We have already seen high performance glass has been discussed today. We have discussed AAC blocks that have been discussed today, because AAC blocks, when compared with brick blocks, cut down the heat that comes into the building. Then there is insulation in the roof, which can cut down the heat coming into the building. Then SRI coating in the roof, which can reflect the radiative component of sunlight into the atmosphere and thereby keeping my building cool. And then I have high efficient plaster for the walls, which is again an insulation parameters which cuts down the heat from coming into my building. And finally, when I do all this and reduce the heat load of the building, I can go for highly efficient air conditioners, which will be lesser in tonnage when compared to a normal building. Let us take a very quick snapshot of how to do this. Now, ECM 1 base case, I require about 6 kilowatt of solar to take care of my building needs. This is a 2-floor villa. It requires 6 kilowatt of solar, and it is going to consume 8,845 units every year. Now, let us see what happens after I start including energy efficient fixtures. Just by including efficient lighting design, my solar capacity from 5.9 drops to 5.8. By putting in efficient fans, it drops to 5.3. As you can see, high performance glazing 5.2, then high performance walls comes to 5.1, then 5 for it drops to further to 5 from 5.9. When I include all this and also include insulation for my roof and SRI painting of my roof, and finally, when I bring in high efficiency plaster for the walls and combine it with very good AC, let us say inverter AC systems, from 5.9 I have come to 3.8 or 4. So if I have a 4 kilowatt system for this particular building, I can take care of my complete energy needs for the whole year. Whereas if I did not design it properly, it would require 6 kilowatt of solar panel. So either ways, both are net zero. Base case is also net zero, proposed case is also net zero. Just that this is much more smarter because it is going to cost you lesser to operate rather than this. So net zero as a concept is an extension of designing the building right. Then it becomes financially profitable, extremely sustainable for the owner, and last but not the least, who would not want to contribute to the environment with a net zero building. All right. So you can see base case 42% was my AC consumption, and this is the base case. But for my main case, because of my energy efficient AC, that is the highest consumer, still lesser than the overall compensation of both if you compare the numbers. And then is lighting is going to be only 50% of the base case. And finally, if you see the green side, 17% to 13% because of energy efficient fans. Last but not the least, I'm going to take a couple of minutes to explain what are the upcoming innovations in the sector over here. We have automation in agro industry, wherein you can create any climatic condition in any place of the world. For example, there are people in Chennai today who are creating Ooty climatic condition to grow leafy greens like bok choy, broccoli, kale, lettuce, spinach, herbs like cilantro, basil, etc., fruits like strawberries. Yes, it can be done in Chennai. Even edible flowers for salad purposes, they are doing that in Chennai. It's an extension of green building, because if you can get an energy efficient and a highly insulated facility, it is very easy to maintain the internal temperature at a particular level without expending too much energy. Demand control ventilation in offices is another IoT, as I told you. Based on the carbon dioxide level, fresh air will be supplied. Home automation, we see the news every day. We see ads, Alexa, switch on my TV, switch on my AC, switch on my geyser, play my music. Those options are there. That is also home automation. It can save a lot of energy. Even let us say you are going to be home in 2 hours, you can switch on the AC 1 hour in advance to make sure it is pre-cooled and kept ready. In textile industry, there is hygroscopic requirements wherein you need to maintain 80% humidity for the threads to have a particular strength. So there automation is used. Automation is used at a smart city level wherein people sitting in one corner of the world can see what is happening to various aspects: energy, water, gas leak, smart energy, traffic management, education. So this is the future. It starts at a building level, but it can go up to monitoring at a community level. Not just that, today's smart design, hydroponic design and automation, irrigation system, all this can be done in from your palm top, just using your phone. IoT in agriculture, this is what I'm talking about. You can also water plants. So this all contributes to the green factor. You can maintain temperature, humidity, you can take a look at, you can recreate weather conditions, just summarizing. Recreating weather conditions, managing nutrients. With sensor, you know if the nutrition has gone down, and you can supply nutrition from a remote area just by having a reservoir tank there. People are doing that. Yes, absolutely possible. For medicine, nutrition, medicine, therapy, and aromatics, all these are possible. You can create very specific, you can grow plants required to take care of so many other needs. Hydroponics again can be taken care from your mobile system. So just to conclude, there is a plethora of opportunity today in the design front, in the operation front, in the retrofit front, in the food growth front, in the vertical farming front, in the health front, everything associated with green buildings. Lot of problems and issues are also there, but with the kind of technology and knowledge available, you have a golden opportunity to be a part of the solution, no matter what the problem is. So with that, I conclude my presentation. I thank you a lot. I thank all of you for the patient hearing, and I probably would want to open the floor up for questions. Thank you so much.
Participants can post their questions in the chat box and unmute and ask the question. Okay, if there are no more questions, okay, here we have a question in the chat box. Sir,
Mr. Vijay has asked a question. What is silicon PP? Please explain it. Silicon PP is a particular type of plaster which is made using volcanic ash. Okay, so what happens is volcanic ash is a vacuum glass ball, and because vacuum is a very good insulator, applying this on walls is equivalent to giving your walls one more layer of brickwork. So it becomes extremely insulative, and because it becomes extremely insulative, the heat coming inside the building becomes lesser. And because the heat coming inside the building becomes lesser, instead of putting 2 ton of AC for a particular facility, you'll end up putting only 1 ton or 1.5 ton. So it gives you a lot of savings by making your walls extremely insulative in nature. I hope that answers your question. Is there any alternative to conventional RCC structures? Yes, Mr. Vijay. Based on the requirements, based on the end use application of the building, today concrete structures are being replaced by PEB structures, pre-engineered buildings. So if it is a load-bearing building, we still go for a RCC kind of structure, because taking into consideration the safety, the longevity, etc. However, if it is going to be a structure wherein the load bearing is going to be very less and the activity is going to be very minimal, then in that case we have so many other alternative panel boards, prefabricated boards, puff panels, so many other opportunities are there to construct a building that is both flexible in nature as well as contributes towards the sustainability factors. Sure. Any more questions? Is there any software to find the temperature of wall or roof at a building at a place? Mr. Lalit, yes, that is possible. That is possible. You can. There are two ways to do it. Number one is the live methodology, wherein you can use probes to measure the temperature at a particular place. Now I understand that is not very easy to do because you can do that only for an existing building. However, with simulation software, you can actually simulate the building and see for a particular external climatic condition what would be the temperature of wall of what would be the temperature of wall or of a roof. So this is absolutely possible.
Sir, I have another doubt, sir. Actually, we are doing a project about paint which can reduce the temperature. So,
Right.
when we apply this in that software, can we find how to apply our project in that software?
Very simple. So which software are you using, if I might ask you?
I don't know what software to use. So, like SketchUp or some other
Okay,
software that we use.
in any energy simulation software, what you can do is get the specification sheet of this particular paint. You will find a value called as the SRI, the solar reflectivity index. Once you plug in this particular aspect into your software or into the simulation model, what the software will do is estimate how much of the radiative heat. So basically, heat has three factors: conduction, convection, and radiation. Convection will happen inside a building, conduction and radiation happens from outside to inside. So conduction cannot be stopped. However, a significant portion of sunlight is infrared and visible ray spectrum getting converted into heat upon hitting a surface. Now this paint will make sure that this heat is reflected back into the atmosphere. How much it reflects back, you will find it in the specification sheet as a value called as your SRI, solar reflectivity index. Generally, for white paint, this is about 90 plus.
Okay, sir.
So I don't see any more. Yes, thank you. How to find a SRI property for a new type of paint? Ruby, the easiest shortcut is to do a very quick CMY comparison. So basically, what I'm trying to say here is white color is 100% reflective, black color is 100% absorptive. So black has a SRI of 0 and white has a SRI of anything between 90 to 100. In certain cases, they also use a slight more glossy finish. It can even go up to 116. It can go to a mirror finish. So very quickly, you can just Google the color and take a look at the SRI. That will give you an indication. However, if you want a, let us say, exact value of a paint and know what is the SRA factor, you can send it to a accredited laboratory. For example, NAL, National Aeronautics Laboratory in Bangalore, can do this testing and tell you what the SRA of the paint is. So you can, for a very quick study or reference, you'll find the data on Google. If you are going to develop something or test a particular combination, you can send it to the lab and get it tested. Yes. Hi, Aslan, please tell me. Yes. So there's a lot of, cannot hear you, so there's a lot of disturbance from your end. So we unable to hear you, sir. There's a lot of noise. You can just, if you could type out your question, sir. So you could type out your question. What I can do meanwhile is students who are interested in the green building sector, who would want to, if you're interested in doing a project or your internship, you can definitely write into me at this particular ID that I'm dropping in the mailbox. We'd be very happy to accommodate you. In case your interest is in the green building sector, please do get in touch. You can just shoot in your a covering letter and your CV would be fair enough. And what project you are working on, my team would be very happy to help you specifically in the green building sector. All right.
Hope there are no more questions, sir. I think students will definitely get back to you. This would do a lot of motivation to them. Your lecture was very interesting. Now I request Pradeepa to propose the vote of thanks.
Yes, sir. A warm greetings to the respected guest speaker of the session, respected HOD, faculties of Civil and other department of SPCE, and my dear friends. This is Pradibha from second year Civil Engineering. It is an honor and privilege to extend the vote of thanks on this special occasion. On behalf of the Department of Civil Engineering, I would like to thank our guest speaker, Mr. Girish R Visvanathan, Director Tech of Earthonomic Engineers Private Limited, who spread time from his busiest schedule to grace the occasion. Sir, indeed, your lecture was very informative and thought provoking. Thank you, sir, for sharing your valuable knowledge on energy efficiency in buildings. We hope to have the opportunity to learn from you in the future, sir. And I would like to thank to our HOD, Dr. Kumada ma'am, for her constant support and guidance. I thank all the faculties and students for their active participation in this webinar and making it a big success. Thank you all. Thank you so much, sir.
Thanks again, sir. Hope to get in touch with you for further interaction, sir.
Thank you so much. Thank you so much.
Thank you so much, sir.
Thank you, sir.
Dear participants, please fill in the feedback form so that the certificates can be sent to you. You can find the link for feedback form in the chat box.